We are going to be solving Cambridge Igcse Chemistry, Paper 1, Multiple Choice, Score, February-March 2026, Paper 12. So let's get started. Question number 1 states that which row shows the conditions for the particles of a gas colliding least frequently. So we need less collisions. Less collision means that we need less pressure, because what is pressure? Pressure is the force that is exerted by the gas per unit area with the walls. So if you have a container something like this and you have gas particles in the container that are colliding with the walls, the force the particles are going to exert on the walls per unit area, force per unit area is going to give you the pressure. So basically pressure should be very low if we need less collisions. More collisions means you have more pressure. Temperature, again, when you need less collisions, if you increase the temperature, what happens? Basically your collisions increase. How do your collision increase? Because increasing temperature means increasing a specific type of energy of the particles, right? When you give more temperature, you give more energy to the particles. The kinetic energy, which is the energy of motion of the particles, increases. So the particles are going to move more frequently, and when they're going to move more frequently, definitely that, like, if this is the particle, it's moving like this, it's going to collide less with this particle, right? But if this particle gains temperature, it gains kinetic energy, it's going to be like this, and then it's going to collide more frequently with this particle. So that means the collisions are definitely going to increase by increasing the temperature, but we want to decrease the collision, so we're going to decrease the temperature. This makes low pressure and low temperature being the causes of less collision. Liquid bromine is placed in a sealed container. Sealed means that done, this is not going to open anyway, and you have some liquid. You know what happens in liquid when we place liquids anywhere, like even if the temperature is not their boiling temperature, if it's not boiling, still the liquid is going to convert into gas anyway, right? That's what liquids do all the time. That's why if it's raining outside and it stops raining, and after 2 or 3 or 4 hours you see outside there's no water, you might be like, oh my god, did the temperature went up to 100 degrees Celsius to make that water disappear? Because 100 degrees Celsius is the boiling point of water, right? But no, the temperature never went up to 100. Then how come the water was just washed off the road? The problem is that water evaporated. After 1 hour at room temperature, the liquid bromine has dash. So that means that liquid bromine has either evaporated or boiled. You know, boiling happens at a fixed temperature. So for boiling, you need a fixed temperature to be there. That means definitely something has evaporated. The second part says that the gas jar becomes completely full of bromine vapor by a process called. So now what's going to happen is that bromine vapor is going to be over here, but now when the bromine vapors are going to start off from here, they're going to eventually spread into the entire room, like this, and then it's going to be like this. This is your diffusion. So diffusion's happening over here. It's going to be option number A, evaporation and diffusion. Which identifies an element, a compound, and a mixture. Element is going to be made up of one type of atoms only. So if you talk about aqueous means that you have water in it, like H2O. So definitely, how can this be aqueous? I don't even read like further. Iron, yeah, iron is only going to be made up of iron atoms that are going to have, I think, 26 protons. So that's going to be fixed for iron. So iron or copper, that makes sense. Second thing, compound. Now for compound, potassium iodide is going to have potassium ions and iodide ions. Will make sense. It's a compound because compound has to be made up of more than one type of atoms. Then we have potassium bromide, potassium and bromine, like this. Yeah, that also makes sense, because yeah, that's correct. Iron again is made up of one type of atoms. That is incorrect. Next we have aqueous sodium nitrate. Aqueous means you have H2O water in it. Sodium means you have N in it, and nitrate means you have NO3 1 negative in it. Sodium means +1 in it. Now you see one thing, compound means that it should be made up of more than one type of atoms, but it should have the same chemical composition. If you look at sodium nitrate, you have 2 compounds in it. One is sodium nitrate, the other one is water. So aqueous sodium nitrate has 2 compounds in it, not a single compound. It's a mixture of compounds. So it's going to be either potassium iodide or potassium bromide. Then next, copper is a element. It cannot be a mixture. Aqueous sodium nitrate is a mixture, but mixture of what? Mixture of two compounds. One is aqueous, that is water, the other is sodium nitrate, which is NaNO3. So over here, this iron copper were elements, potassium bromide and potassium iodide were compounds, and aqueous sodium nitrate and aqueous sodium chloride were mixtures. So all three correct are in this option. X and Y are both atoms. Atoms means that same number of protons and electrons, but neutrons can be different, okay? X and Y are isotopes of the same element. Same element means that, the same number of protons, not electrons. I always tell people that how come they confuse this thing that isotopes or same element means that same number of electrons. No, only proton number makes an atom of a certain thing. So if it's iron, all iron atoms are going to have 26 protons. Electrons, iron ions are going to have different electrons. Electron can change. They can go out of the atom, they can come into an atom, but protons, they can never change in a single type of atom. If the proton change, the atom changes. From iron, it's going to become something else. It's going to become the one with 27 protons. That's going to be different. Which row describes the atomic structures of X and Y? They told us that X and Y are isotopes of the same element. Same element means the proton should be same. So 6 over here and 6 protons in Y as well. This makes sense. 6 protons here, 6 protons. This makes sense. 6 protons in X and 16 protons in Y does not make sense. I quickly just cut this option out because the proton number is changing. For isotopes, we need same proton number. 7 protons and 6 protons again does not make sense. Next, there are isotopes. Isotope means same number of protons, a different number of neutrons. So neutrons should be different. Over here we have 6 neutrons. Over here we have 6 neutrons. Well, it doesn't make sense. But you need to realize one more thing as well. X and Y are both atoms. Atoms means same electron and proton number. Because if you have ions, it's going to be charged. Electron number can be less or more than the protons. That's going to be different. But for atoms, we need the same number of electrons and protons. If you look in option number A, 6 and X, which makes it an atom. But for Y is not an atom because Y have one more electron than proton. So Y is a -1 ion because look, proton 6, electron 7, not an atom. We were looking for atoms. But for X is an atom because same number of protons, 6 protons in X, 6 electrons in X. Y is an atom because 6 protons in Y, 6 electrons in Y. And X and Y are isotopes of each other. How come they be isotopes? Because 6 neutrons in X and 8 neutrons in Y, neutron number different. So that means option B is going to be correct. An atom forms an ion with a positive charge. Positive charge means that if you have Y, it is a positive one, more protons than electrons. Positive charge means this thing. 4 statements about the atom and the ion are listed. The ion is an anion. No, it's a cation. Cation are positive ions. The ion is cation, right? There are fewer electrons in the atom, in the ion than in the atom. Yeah, that's correct because they're going to be, obviously, if you need to have more protons than electrons, you need to have fewer electrons. That makes this correct. There are more protons in the ion than in the atom. No. Always remember, if the proton number changes, it no longer remains the ion of the same atom. It changes. Proton numbers don't change in your Igcse chemistry. It's never gonna change. So anytime it's written the proton number changed, the protons were less or this, that means it's incorrect. So option number 2 and 3. Never change it. Which row describes the type of bonding present in substances 1 and 2? Okay. Methane has ionic bonding. That's complete lie because methane is carbon bonded to 4 hydrogens. And you know that when carbon and hydrogen bond together, they form a covalent or ionic bond. Definitely carbon and hydrogen can never form an ionic bond. Never, ever, never. They always form covalent bonds because no one has the capacity to take electrons from the other. They have to share. It's their It's their necessity to share. They cannot take away. So cross. Ionic bond means full transfer of electrons. In ionic, you cannot share. Hydrogen chloride has covalent bonding. That's correct, uh, but we are not gonna make option A correct. We cross it out because this one's incorrect. Hydrogen chloride has ionic bonding. No, it is covalent. Now you might think, how come this is P2? Yeah, that's correct. HCl is a covalent compound. This is your chlorine and this is your hydrogen. This is your hydrogen. And there is a pair of electrons that's being shared between the two like this. So that is your HCl, which is a covalent compound. And now you might think, oh my god, how is this possible? Hydrochloric acid, you have hydrogen ions and chloride ions, then how come HCl be a covalent compound? You're extremely correct. But HCl becomes ionic when it comes in water. That is when it makes your hydrogen ions and your chloride ions, and that's when you think that it's an acid because it's donating a proton. Yeah. So this thing is only going to happen in water. Next, they're saying that potassium chloride has ionic bonding. Well, that's correct because potassium is going to lose one electron. It is in group 1. It has 1 electron in its outer shell. Chlorine is in group 7. It has 7 electrons in its outer shell. It just needs 1 to get 8. So it's going to take that 1 electron from the potassium. It's going to transfer. So there's an ionic bond. In ionic bond, there's a transfer of electrons. That's correct. Sodium bromide, same. Sodium, the problem is that sodium has 11 protons, right? And the potassium, it has 19 protons. That's the only difference. And for bromide and chloride, both, they're just going to gain one electron. So that's the same thing but with different atoms. So potassium chloride, they took bigger cation and smaller anion. The chloride ion is going to be a smaller one. And for the sodium bromide, they took a smaller cation. Sodium is going to be a smaller cation and they took a bigger anion. So that's the only difference, but both are going to be ionic bonds. Well, if you think about it, no, just don't think about the strength of the bonds. Methane has covalent bonding. Yeah, that's correct because methane has 4 carbon-hydrogen bonds. They're going to be purely covalent sharing of electrons, which makes option C the correct answer. Diagram XYZ shows part of a polymer structure and 2 giant covalent structures. So polymer means that there's going to be a continuity of covalent bonds, endless covalent bonds, and giant covalent structures as well means endless covalent bonds. But still, polymer structures are not like as in terms of structure specific in your syllabus, but the giant covalent structures are structures specifically in your syllabus. They are diamond, graphite, and SiO2, which is silicon dioxide, and that's also called your sand or mud. Which row shows the structures with the correct use? Diagram cutting tools. You know what's used in cutting tools? Diamond. And why is diamond used in cutting tools? Because diamond is extremely strong. There's a quote that diamond cuts a diamond because diamond is so strong that it cannot be cut by any other material. It needs a very strong thing to cut it. And similarly, because if it's strong covalent bonds, because the valency of carbon is 4, when it makes 4 bonds, it's extremely stable. It doesn't want to break those 4 bonds. So diamond has an extremely stable structure because of the strength of these 4 covalent bonds that carbon atom has made. So diamond is going to be used in cutting tools. Next is reduces friction. Reduces friction means it's going to provide you lubrication. It's going to be used as a lubricant. And what can be used as a lubricant? Definitely graphite. Why? Because it has these weak intermolecular forces between the 2 layers of graphite. The above one is the first layer of graphite and the below one is the second layer of graphite, and between these 2 layers, this thing is going to be the one that's going to make it a good lubricant, because when you apply force, the layers can slide over each other. So that's the same thing that's going to happen when you write with pencil. The layer of graphite gets stuck on your paper. So cutting tools is going to be Y, that's diamond. And reduces friction is going to be Z, that's going to be graphite. And this X was a polymer. aqueous copper 2 chloride reacts with aqueous sodium hydroxide. Copper 2 chloride is a salt. Sodium hydroxide is also an ionic compound. What is the equation for this reaction? This is going to be a double displacement reaction. You're going to form copper hydroxide and sodium chloride. So how do you do it? Copper 2 chloride. 2 means copper is a charge of positive 2 and chloride always is a charge of negative 1. That means you're going to require 2 chlorides. So it's going to be CuCl2. This thing, cross. No 2 coppers, 2 chlorines. This and this tick. Next thing. Take NaOH. Now look at this thing. Copper was a 2 plus and hydroxide was a negative 1. So you basically needed two hydroxides to balance out the charge of copper 2 plus, because look, copper is a 2 positive, and to balance out 2 positive you need a 2 negative, and one hydroxide is a 1 negative, so 2 are going to be 2 negative. So that's the equation. So just even if you don't know the equation, just by looking at the charges, that this one's a 2 plus, this one's a negative 1, you can simply just figure out the correct option, which is option C. What is the definition of relative atomic mass of an element? It is 1/12 of the mass compared to the mass of carbon 12. That's the thing. So now there are going to be a lot of wrong definitions, and they're going to be very lucrative, intimidating to those who don't study. The average mass of the isotopes of the element compared to 1/12 of the mass of an atom of carbon 12. That's the first definition. Okay, now let's read the second one. The total mass of the isotopes of an element compared to 1/12 of the mass of a carbon 12. Second one just like the first one, but they're like very tiny differences if you can spot. Third one, the average mass of the isotopes of an element compared to the mass of hydrogen 1. Okay, just by looking at hydrogen 1 I crossed the C and D, but out of A and B, what's going to be the correct one? The total mass of the isotopes of the element compared to 1/12 of the mass of a carbon 12. The average mass of the isotopes of the element compared to 1/12 of the mass of a carbon 12. So now the only difference, if you're able to spot, is the first one has the word average mass of the isotopes. The second one has the total mass of the isotopes. So if someone doesn't know, he doesn't know. He cannot pick this up if someone hasn't understood this thing, that you don't have the total mass of all the isotopes, you have the average mass of the isotopes. Right? You take out the average. If you have the total mass of all the isotopes, it's going to be like so much that it's not going to be considered that atom. You're trying to justify a single atom. So if you take the total mass of chlorine 35 isotope and chlorine 37 isotope, so 35 plus 37, what does that make? 7. That makes 12, 6, 7, that makes 72. So 72 is not the mass of chlorine. It's 35.5. Right? So it's not the total mass. The total mass is going to be 72, but the average mass is going to be 35.5. Okay, so it's going to be this thing. Which substance can be used as an electrolyte in an electrolysis experiment? To have an electrolyte, you need something that can conduct electricity, right? Ethanol is a polar solvent. Yeah, that's correct, but it's an organic compound and we don't prefer organic compounds. Next we have molten lead, we have graphite, and we have aqueous sodium chloride. Now the thing is, to have an electrolyte needs to have positive and negative ions. Yeah, why positive and negative ions? So they can move towards the anode and cathode. Molten lead does not has negative ions. It has electrons but not the negative ions. Next, question number 11 states, what is formed at each electrode when molten sodium oxide is electrolyzed using inert electrodes? So firstly, we are talking about the anode, and then we're talking about the cathode. We need to realize that we have molten, that means there is no water molecules in it, and we have sodium ions, which are going to be Na positive ions, and oxide ions, which are going to be O2 negative ions. Now you need to realize one thing, that sodium ions are positive ions, and positive ions are attracted toward the negative thing, and cathode is negatively charged, whereas your oxide ions are negatively charged, so they're going to be attracted towards something that is positive, and anode is positively charged. So you have no water. Why you have no water? Because you're dealing with a molten substance, not with aqueous. So if it was aqueous, then you would have hydrogen ions and hydroxide ions from the water, but now you only have oxide and sodium. So at cathode you form sodium, And at anode, you form oxygen, which makes option C. This was easy. Which row describes the changes during an endothermic reaction? So endothermic means that energy is given out or taken in, is taken in. So what's going to happen is that I explain this thing like this. You have this box. Imagine you have this box, okay? And this is your substance in the box. Now, if it's an endothermic reaction, the box is going to take in energy from your surroundings, something like this. So the energy is going to go into the box. If the energy is going into the box, like here is all the energy, and the energy moves into the yellow thing. So the energy of the surrounding, this green part is the surrounding, and the energy is going from the surrounding into the yellow part. So energy in the surrounding will decrease. So your surrounding temperature is gonna decreases. That's gonna happen in your endothermic reactions. Transfer of thermal energy taken in from the surroundings in endothermic, and temperature of the surrounding decreases because energy moves from this part to this part inside the thing where reaction, so temperature has to decrease. An experiment is done to find the rate of reaction when 1 gram of solid X reacts with 100 cm cube of solution Y. So this is solution Y. We have 100 cm cube of this, and then we have solid X. We have 1 gram of solid X. Up now you need to realize one thing, that in this reaction we are producing a gas. So gas is present over here, okay? So from here we are gonna release some gas, and the gas is gonna move through this tube to here. The experiment takes place too quickly for measurement to be made. Which change can be made to slow down the reaction? एक second. First, tell me that we're collecting the gas. So what's happening to the time? The time is too fast. You need to realize, because we have to measure the rate, we need two things. One thing is going to be the volume of the gas collected, and the second thing is going to be the time. So time is basically too fast. We need to slow down the time. For that we need to lower the reaction. Which change can be made to slow? Add a catalyst. Catalyst always increases your rate of reaction. So that's across. Decrease the concentration of solution Y. Okay, so now I need to realize we need to slow down the reaction. So if we decrease the concentration of solution Y, we can slow the reaction, because more concentration means faster reaction. Because look, if I have this box here and this box here, and both have particles, 1 2 3 4 particles here, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, 4 times more particles here. So now you need to realize that a reaction happens when the two particles collide with each other. So when they're going to collide, the reaction is going to happen. In this container, you can see it for yourself that there are more particles. The container size for both the containers is almost equal, right? But there are more particles, so they're going to more collisions are going to happen here. So faster is going to be the rate. So if I decrease the particles, I can decrease the collision. So it's going to be decrease the concentration, decrease the particle size of solid X. Now if I decrease the particle size of solid X, what will I do? When you decrease something's size, what do? You increase the surface area. So decreasing the size of the solid is gonna increase the SA, surface area, and when you're gonna have more surface area, you're going to have more collisions. Decrease the particle size of solid X? No, that's gonna increase the rate. Increase the temperature again. If you increase temperature, you increase the energy of the particles, and when you increase the energy of the particles, the kinetic energy of the particles, you increase the rate of the reaction. Which type of reaction occurs when water reacts with anhydrous cobalt 2 chloride? Reversible, displacement, neutralization, redox. Reversible. Why? Because look, this is anhydrous cobalt 2 chloride. Anhydrous means that it lacks water. Anhydrous means that it lacks water. So basically there is no water in it. If I add water to it, cobalt 2 chloride, you should know, is blue color. So let me just draw it with blue color. This is cobalt 2 chloride, that's blue color. If I add water to it, we can use some darker blue for water, like this. Yeah. So if I add water to it, this is my water. This is such a nice color, royal blue. This is gonna turn into pink color. So, and if I remove water from it, it's gonna turn back into blue color. So this is a reversible reaction. Even with copper 2 sulfate, if you add water to it, it turns blue. If you remove water from it, it turns back into white color. So basically these are your reversible reactions, and they can happen if you add water, the salt changes color, and that's also used to test for water. Displacement happens with your halogens. Neutralization happens with your acid bases. Redox happens with your when a more reactive metal replaces a less reactive metal, or with the displacement reactions, they're redox reactions. Nitrogen and oxygen can form the compound nitrogen 2 oxide. Which statement about Roman numeral in the nitrogen 2 oxide is correct? That means that nitrogen has a charge of 2 positive here. The Roman numerals always tell the oxidation numbers. If you're dealing with a copper something and the name is copper 2 sulfate, the Roman numeral over here always tells you the oxidation of copper. That means copper has a 2 positive charge, because look, when you're dealing with transition elements, transition elements are the ones that have variable oxidation states. Because they're variable oxidation states, you write it in the bracket like this. Look, cobalt 2 chloride, that means cobalt CO is going to have a charge of 2 positive on it. Got it? Which statements about the Roman numeral in nitrogen 2 oxide are correct? It indicates that the oxidation number nitrogen is positive 2. Yeah, that's correct. It indicates that the oxidation number for oxygen, no, not for oxygen, for nitrogen. It indicates that the formula of nitrogen 2 oxide contains 2 nitrogen atoms. No, that's completely incorrect. Only 1. Okay. What is the color of thermophthalene in dilute sulfuric acid? So basically this is an indicator. You should learn its colors. So number 1 is in acids and number 2 is in a base. In acids, it's colorless, and in bases, it's blue. So we are dealing with sulfuric acid. So with sulfuric acid, it's gonna be colorless. Which word describes a metal oxide and an alkali? A metal oxide and an alkali. Metal oxide is gonna be acidic or basic. Obviously metal oxide is gonna be basic, because you're dealing with an oxide like zinc oxide. It's gonna react with acids. So this is basic. Next thing, alkalis are soluble bases. You should always learn that alkalis are soluble bases. The periodic table shows the position of 4 different elements. Which row is correct? This is definitely going to be a metal. You know, these 3 rows, like this entire part, I think that's for metals. So element number of electrons in the outer shell, that is the period number, that is the group number, group 1, group 2, 3, 4, 5, 6, 7, 8. A number of electrons in the outer shell, 1. A second, the periodic table shows which row is correct. So why is there ABCD over here? The periodic table shows the position of 4 different elements. So they're saying A is a non-metal and it has 1 electron. No, A is going to be a non-metal but it has 4 electrons, right? So A is going to be carbon, I can see. B is a metal but it's going to have 4 electrons. B is going to have 3 electrons. So incorrect. C is going to be a metal. Yeah, it's going to be metal and it's going to have 3, no 1. 1. C is going to have 1 electron. And then you have your D, which is going to be a non-metal. Yeah, that's correct. D is a non-metal and it has 7 electrons in the outer shell. That's going to be correct. Why? Because D is in group number 7. Okay, next thing. Rubidium is group 1 metal. It has a density of 1.53 gram per cm cube and a melting point of 39 degrees Celsius. Cesium is also a group 1 metal. Which statement gives the melting point and the density of cesium? So firstly, it's group 1, right? It has density this and melting point this, rubidium. So you should know that you should consult the periodic table first thing and realize that rubidium is above cesium, and down the group the density increases and the melting point decreases, right? Rubidium is above cesium. So rubidium, cesium. And I need to check one more thing. Okay, done. Now we realize that since rubidium is above, it should be less dense. So cesium is going to be more dense. And second thing, the melting points of cesium should be less. Why it should be less? Because down the group the melting point decreases. So it's going to be 29, which is less than 39. So for 2 points for this MCQ is, should write down group 1, melting point decreases, and down group 1 density increases. Always remember, in all the periodic table, down the group the density is always going to increase because the mass number of the thing is increasing. So density always increases down the group. Which statement about iodine is correct? It is monoatomic non-metallic element. Oh my god, it's monoatomic? No, it's diatomic. It's iodine, it's a halogen, it's I2. Halogens are like this. It's a solid at room temperature and pressure. That is correct. Down the group, fluorine, bromine, iodine, and astatine. So down the group, what happens with halogens? Their physical state becomes more, like it becomes more solidified. Fluorine, chlorine are gases, bromine is a liquid, and iodine and astatine are solids. Got it? So I write it down that these two are gases, then this one's gonna be a liquid, so the physical state's kind of becoming more solid, and these two are gonna be solids. Okay, it is less dense than bromine. No, the density is increasing as well. It is more reactive than chlorine. No, the reactivity decreases. So there's a more important point that the reactivity decreases down the group. Platinum is a transition metal. Which statement about platinum is correct? It's transition element. It does not catalyze reaction. It will, because transition elements are good catalysts. It forms colored compounds. Which statement about platinum is correct? This is correct, because that's a habit of transition elements, that they're going to have variable oxidation states, they're going to be used as catalysts, and they're going to catalyzed reactions. You can have high density, high melting boiling point. So low density, low melting boiling point is not making sense. Copper is sometimes used to make cooking utensils. Good. The properties of copper are listed. Corrosion resistant, good conductor of electricity, good conductor of heat. Which properties make copper suitable for making cooking utensils? Okay, for utensils we don't care about corrosion, right? For utensils we care about corrosion. Yeah, utensils shouldn't corrode. We don't care about the electricity part, right? So I think we don't want it to corrode, and we want it to have good heat. So 1 and 3, because obviously it has to have this gas ring over here, so it needs to be resistant to heat, and should like be a good conductor, so it can warm the water or whatever food is inside this. Magnesium is a typical metal. 3 reactions of magnesium are listed. Magnesium plus oxygen gives substance X. Magnesium plus steam gives substance X plus Y. Magnesium plus sulfuric acid gives substance Y plus Z. What is substance Z? Okay, so it's a metal, and you add metal with sulfuric acid, you get a salt and you get hydrogen. So either substance Z is a salt or a hydrogen. Magnesium plus steam, when you add magnesium plus oxygen, is going to be MgO, right? Magnesium oxide. So this is magnesium oxide, and plus you're going to form hydrogen. You're adding water to magnesium. Yeah, you're going to form hydrogen gas. So substance Y is hydrogen, right? If substance Y is hydrogen, that means substance Z is going to be a salt, and that's going to be magnesium sulfate, because you have magnesium and sulfuric acid. So that's going to make you magnesium sulfate, MgSO4. Which statement explains why? Why is stainless steel used to make cutlery? Why is stainless steel used to make cutlery? It is softer than pure metal? No. Stainless steel is more stronger. It is more resistant to rusting than pure metal. Yeah, that's correct. More resistant. Why? Because steel is basically when you add carbon to iron. Look, iron is going to have arranged atoms like this in a straight line. So they're going to be like this. Let me just draw them. That's going to be your iron. Now let me draw your stainless steel. Now realize one thing. This is iron and this is stainless steel. So iron is soft, because when you're going to apply force, the layers, these are your layers, they're going to slide over each other because iron is soft. But stainless steel is pretty hard because you have these different sized atoms. It's going to be difficult for the layers to slide over each other. Got it? Equations 1 and 2 represent two reactions that occur inside a blast furnace. Which type of reactions are 1 and 2? 1 is going to be redox. Why? Because look, there's a metal involved in it. Iron is a 0 here, and over here iron is a 3 positive. So oxidation state changing. So 1 is redox, and 2, look, you have a carbonate, and a carbonate is thermally decomposing into this and this. Got it? So that's thermal decomposition. Option number B. 4 processes are listed: filtration, sedimentation, distillation, chlorination. Which processes are used in the treatment of domestic water supply? Filtration, sedimentation. Distillation we don't use in the treatment. We use distillation to get the water out. Okay, but not in the treatment. For treatment, we filter it, we sediment it, and we chlorinate it. So 1, 2, and 4. Distillation is just used to obtain like normal distilled water, but not the home water. Which statement explains why river water containing NPK fertilizers is harmful to aquatic life? Because it causes eutrophication. NPK fertilizers can cause disease. No, NPK fertilizers contain harmful microbes. No, NPK fertilizers causes deoxygenation of water. Look, all the options were quite invoking and intriguing, but you had to realize that we're talking about the deoxygenation of water that happens in eutrophication, because it's gonna cause excessive algae growth, and if excessive algae is gonna grow on the surface of water, then it's gonna die, and then bacteria is gonna decompose it. So the bacteria is gonna use up the oxygen, and that's gonna cause the lack of oxygen for the remaining organisms in water. NPK fertilizers contain plastic particles. No, they don't. Which gas approximately 21% oxygen, nitrogen is I guess 78, carbon dioxide is 0.04, argon is almost 0.9. I don't know if I'm correct, but that's my random guesses. Carbon dioxide is naturally present in air. An increased amount of carbon dioxide in air is causing global warming. That's correct. Increases in carbon dioxide is because of using diesel vehicles. Yeah, that's correct. Wind generation, no. Reduction in livestock farming. Reduction? I don't think that's correct. Decrease in carbon dioxide is because of planting trees. Makes sense? Easy. Structures of 3 compounds are shown. We have 2 carbon atoms, and we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 single bonds. So that's gonna be carbon and carbon. That's gonna be ethane. Next, we have 1 carbon, and we have bromine attached to it. Carbon and bromine, so that's gonna be bromo. But since we have carbon, so that's gonna be bromomethane, right? Because 1 carbon is methane. So we have bromomethane, then we have 1, 2, 3 carbons. So we have 3 carbons, and then we have a bromine. So that's 1 bromo, but 1, 2, 3. So that's a propane. Okay. Next, which statement explains why these 3 compounds have similar chemical properties? Because all of them have a bromine attached to it. So that's your bromoethane, since I missed out on the bromo part. Which statement explains why these 3 compounds have similar chemical properties? They all contain bromine, carbon, and hydrogen. They all contain the same functional group. Yeah, they all contain the same functional group. That's a halogenalkane, and the chemical properties of a substance is determined by the functional group. Remember this thing. Always remember this thing. So it's going to be the functional group. Yeah, they contain bromine, carbon, and hydrogen. I agree, but I am going to draw a compound. Now look over here. This compound also contains your carbon, oxygen, hydrogen, and bromine, whatever they're talking about. Just let's exit the carbon. But they contain the 3 essential parts, but still it's going to give a different a different result. Why is this going to give a different result? Because this is going to give a different result because it does not have the same functional group. Then they're like this carbonyl functional group and there are more things to it. So you just need to realize it's not about the atoms, it's about the functional group. Which row shows the correct information? So displayed formula is for an alkene, yeah, that's ethene. But you need to realize this CH3 over here, so that does not become ethene, that becomes propene, because the straight chain is going to be like this. That's going to be the straight chain. There's just like a little bend to it that makes you think it's propene, but it's that makes you think it's ethene, but it's actually propene. This is ethanoic acid. No, there's no acid part to it. Acid means that you have carbon double bonded oxygen and then you have oxygen and hydrogen. So this is your acid, this is your alcohol, so this is your ethanol. Next you have ethane, yeah, that's correct. 2 carbons, ethane, and that's your alkene. Next you have ethanol. Know that this is ethanoic acid, that's the acid part. Next, X, Y, and Z are fractions obtained from the fractional distillation of petroleum. The diagram shows the relative volatility of the fraction. So volatility means your ability to evaporate. Okay, the use of fraction X. Increasing volatility, so that's going to be the most volatile, so that's going to be used for cooking, I think. And the least volatile, okay, then use of fraction Y, chemical feedstock, and then use of fraction X, fuel for diesel engines. Yeah, the least volatile should be fuel and the most volatile should be the cooking thing. So that's what I think. Making roads, no, I don't think. That's my just like the instinct part. Which statement about alkenes is correct? Alkenes are saturated? No, they're unsaturated. Alkenes are hydrocarbons with the general formula. No, that's the general formula for the alkenes. So it's that alkenes are gonna be brown when you add bromine to it. Randomly you add bromine, but what it's gonna do is that this carbon double bond in the alkene, it's gonna break it. One bromine is gonna attach to this carbon and the other bromine is gonna attach to this carbon. So it's gonna, now this thing is gonna be colorless. Okay, so it's gonna become colorless. So from brown to colorless, that's correct. Alkenes give color change from brown to colorless. Alkenes are manufactured from larger alkene molecules in a process called combustion. No, it can be through cracking but not through combustion. Ethanol is burned in some camping stoves for cooking. So in some camping stoves for cooking, which statements about the use of ethanol in camping stoves are correct? Ethanol acts as a fuel when it burns. Yeah, that's correct, it's a fuel. Ethanol burns to produce carbon dioxide and hydrogen. No, carbon dioxide and water. The reaction that takes place between ethanol when ethanol burns is exothermic. Yeah, that's correct. Obviously, that's why it's going to release heat. The reaction that takes place when ethanol burns is endothermic. 1 and 3. So 1 and 3. Which solids react with dilute ethanoic acid to produce a gas? Which solids are going to react? You have an acid, you add a metal to it, you are going to produce hydrogen. You have an acid, you add a carbonate to it, you're going to produce carbon dioxide. But with oxide and hydroxide, you're going to produce salt and water only. So 1 and 4. In 1, you're going to produce, 1 is going to be basically acid plus metal gives salt plus hydrogen. And the 4th one is going to be acid plus carbonate is gonna be salt plus CO2 plus water. 4 statements about polyethylene are listed. It is a plastic. Yeah, it is a plastic. Polyethylene. It is formed from addition polymerization of ethene. It is formed by addition polymerization. Yeah, it is formed from small molecules called polymer, from small molecules called monomers. It burns to produce carbon dioxide and hydrogen, carbon dioxide and water. So 1 and 2. The diagram shows liquids in a burette and a measuring cylinder. Okay, so from a burette you read like this is gonna be 27.5678. So that's 27.8 you read from above, and in the measuring cylinder you read from below. So that's 27.8. But for this part you need to realize this is your 40, this is 42, then this is 44, this is 46, this is 48, and this is 50. So 40, 42, 44, 46, 48, and the last one's gonna be 50. So that's 44. Got it? Next, the diagram shows a chromatogram of an ink sample with and 4 other dyes that are 1, 2, 3, and 4. Which dyes could be part of the ink sample? So which dyes are part of the ink sample? Number 1, this is ink, so I need these two in something, and then I need this in something. So 4 is part, and then 2 is part. So it's 2 and 4. Why? Because look, the 2 has this and this, which matches with this and this, and 4 has this and this, which matches with this and this. This thing, and this thing are not in it, so 1 and 3 are not. Next, aqueous sodium hydroxide is added to solid X and the mixture is heated. A green precipitate is formed and an alkaline gas is given off. Which ions are present in X? Which ions are present in X? So aqueous sodium hydroxide is added and a green precipitate is formed and an alkaline gas given off. So alkaline gas is going to be the ammonia gas, so ammonium, and green precipitate is formed, which is for iron 2. Iron 3 gives a red brown precipitate, so that's going to be option A, and we're done and dusted. This alkaline gas is your NH3 gas, that's ammonia.